Hi girls, and welcome back to my channel. Today I'm going to be talking about SUVAT equations, which is a particular area of physics where you look at the movement or path of something moving. So first we're going to look at what SUVAT actually stands for. S stands for displacement. Displacement is a directional movement. So you might say 2 meters right, or like 3 meters north, 2 centimeters south, that kind of thing. Now U stands for initial velocity. Initial velocity is the starting velocity when your movement first starts. And that's measured in meters per second. This V here stands for final velocity, which is at the end of the question, what velocity is it at, and it's also measured in meters per second as its standard unit. Acceleration is the rate at which something gets faster or slower, and that is going to be measured in meters per second squared. Do not leave out the squared, it's very important to get your units correct. As for T, you probably guessed, it stands for time, and time is measured in seconds also. Now, we also have unit abbreviations for these, and so for displacement you have meters, which is just m. Initial velocity, which is meters per second, is meters over seconds, or meters seconds to the power of -1. Same with final velocity. And acceleration is meters over seconds squared, or meters seconds to the -2. And of course S for time, which is in seconds. Now we're going to look at the SUVAT formulas. These are the formulas you will use to solve your SUVAT equations. First we have V equals U plus AT, and so on. There are 5 of them. Some people only acknowledge 4, and you can derive the 5th from the 4th, but I like to just have as many options as possible just to make it less rearranging at the end of the day. Pretty much, once you know your SUVAT equations, often in exams they'll actually give you a paper which tells you all of them. You need to remember you will often need to rearrange. So rearranging is a really important skill that you should learn. I will do a video on that one too. Also, your chosen formula must contain your known values and only one unknown value. This way you can solve your equations. your questions. Okay, let's look at an example question. In this question, first you always want to in a SUVAT question, is find your values for each thing. So our acceleration is something we don't know. And we also don't know the distance, which is displacement, because it's a direction. The car's going in a particular direction. So we don't know S, we don't know A. What do we know though? We know that it starts from rest, and obviously if something's resting, it means that it's at a stop. So the initial velocity of this question is 0 meters per second. We're also told what speed it is at the end of the acceleration, and that's 15 meters per second. So that will be our final velocity. As for time, we are told 10 seconds, so that is our time. The next step is to look at our list of formulae, I don't know how to say it, the list of formulas, and go, okay, what don't we know and what do we know? Well, we don't know the acceleration and displacement, and that's what we need to find, and we do know the initial velocity, the final velocity, and the time. So we're going to be working with those. Now to find the right one, all we need to do is go, okay, well we need to have A, U, V, and T in it, and that is the first question, has all of those things. Now, taking our equation of V equals U plus AT, we're going to rearrange that. Now, go check out my rearranging video, which I will post soon, hopefully, and that will explain how to rearrange any equation, and V's just rearranged just like any other equation. Then add in your values from your list to replace the letters, and you get your answer. It's pretty basic. You're just filling in a formula. That's all you need to do. So once you can recognize them and fill and rearrange the formula, pretty much your work's done. You just do the calculations and ta-da! Now this is our second part of the question, where you want to know the displacement. For this question, since we already know the acceleration from the previous one, you can use something that has an A in it. Now, using our calculator, because I was too lazy to figure out what 15 times 5 was, we find that the displacement is 75 meters. So our answers is acceleration is 1.5 meters per second and displacement is 75 meters. Now for another one. So do the exact same thing, find your values for each of your SUV and T. Obviously there will be one or two that are always missing, and those are the ones you either need to solve both for or just for one. And so I'm plotting all these in. Remember, if something starts resting, it is actually meaning that it's still at the time, so then it's going to be 0 meters per second. Then we're going to go back to our formula page and find what we do and don't know. And we don't need to find acceleration because it doesn't want us to know acceleration, so you can ignore the A completely. Now looking at what we do know, we do know and also what we don't know. So what do we know? We do know the displacement, we know how far it's going, we know the time, we know how long it's taking, we know the initial velocity, it's starting from a rest, and we don't know the final velocity. We also don't know acceleration, but we don't need to know about that because the question doesn't ask us to figure that out. So obviously, you know, the S, T, U, V, A, all the symbols, then we use the symbols we know, okay, and one that we don't know, and we find a formula that includes all those letters and no others. So this formula has no A in it, very important, because we don't know what A is. You can only ever solve for one unknown value, so make sure there's only one unknown in your formula. Now we're going to rearrange this one, pretty basic, and then once we've rearranged it, we can just work it and solve it out. Rearranging is quite a difficult skill, so definitely practice a lot of rearranging, and that will really help you excel in SUVAT questions. Sometimes, as you can just see, I made a little bit of a mistake. I didn't take too much effort to fix it. I just went, oh, hang on, I made a mistake. I didn't rearrange it properly. So you go back. If you're getting weird results, then you know you probably rearranged it wrong. If you're not sure, go to the final answer and then check it with the answer sheet if you have an answer sheet for your question. This one took a bit of time to rearrange. Some of them are faster than others. In fact, sometimes you don't even need to rearrange it at all. I think some of the questions I was doing don't need too many rearranging steps. Now, as before, just go in and fill in all the values. So we know, oh, by the way, if you have something on between equals, you can always flip it. I like to have my unknown value on the left-hand side. That is just a personal preference. It works either way. Fill in the values and do the calculation. Let me get out my calculator. Oops, where's it gone? There we are. And put in our numbers. 80 divided by 12. Here we go. Okay, 6.666666. It's an infinitive. So put a line over it, or you can also round it to the nearest, whatever you want. I chose to the nearest 2. And because it's rounded, I have to do that wiggly equal sign to show it is not quite accurate. And so our answer is, the final velocity is 6.67 meters per second. And that is the answer for question example number 2. Now let's go into another one. This one's different because it looks at deceleration or negative acceleration, which is when something's slowing down. So we will fill it in like normal, only this time it actually starts with quite a fast speed. It's going at 100 meters per second, and then it comes to a complete stop. So the V this time is actually the 0 meters per second squared instead of the other way around. Now time, like normal, is time, and we don't need to know displacement. We're looking for the acceleration. So how fast is this getting slower? It sounds funny. Okay, so what do we know? We know the initial velocity, we know the final velocity, and we know the time. What we don't know is we don't know the displacement or the acceleration. But this time we just want to know the acceleration, or in this case kind of like deceleration or negative acceleration, because it's getting slower, it's not speeding up. So ignore the displacement, find the correct formula and write it down. This one was a really easy one to rearrange, as you can see. It took like 2 steps. Then just plug in the numbers you know. Okay. I got it wrong. I wrote 20. I don't know why. And I also wrote 5 wrong. Okay. And we get negative 20 meters to the power, meters per second squared. Now the reason it's negative is because it shows that the train's actually decelerating or like slowing down. The train's going from a fast speed to a slow speed, or in this case a complete stop. So that's the negative symbolizes that it's actually slowing down, it's not getting faster. Okay, so in revision, the 3 SUVAT steps are as follows. I like decorating my pages, it makes the notes more interesting to look at later. These are important to remember. Okay, first one, list your known variables, then select the formula and arrange, and finally insert your known values and solve, of course, my favourite part. So thanks so much for watching. I hope you enjoyed this video. I'll post one on rearranging, and be sure to check that one out too. Bye for now, and work on your SUVAT equations.